Now we use the fact that the net force is equal to the centripetal force because the motion is circular. We say mg, because mg plus t turns into mg, right? Because the turning point where the bob it either wraps around the peg or it just flops and doesn't wrap around, that's when the tension becomes zero. And that means that the net force is mg plus t, and since t is zero, it's mg. So the net force is equal to mg. Set that in equal to the centripetal force, and you have mv3 squared over r. Remember, centripetal force is mv squared over r. Alright, so next step. Alright, so let's summarize the two results. Using energy arguments, we found that mg times L minus 2r, the potential energy, the energy left over from the potential energy was mg2r at the top of the peg, right? So the kinetic energy is whatever is left over, which is mg times L minus 2r, and that's set equal to 1/2 mv3 squared. Now from the argument above about forces, we found that mg is equal to mv3 squared over r when the tension the tension becomes zero at the top of the motion. Right. Now using the first equation, this one, okay, using that, we have mv3 squared equals mg times 2mg times L minus 2r. So I brought the factor of 1/2 over to here to get this result. Right? Now plug this into 2. Okay? Plug that into here. Right? So mg equals mv3 squared over r, and we plug this into mv3 squared, and we get mg is equal to 2mg times L minus 2r divided by r. Alright, now cancel out the factor of mg from both sides of the equation, right here and right here, and you get the following. 1 equals 2 times L minus 2r divided by r. Now we solve for r, and we get r equals 2L minus 4r. You move the r to the left hand side of the equation to get 5r equals 2L, and you get r equals 2/5 L. Next, since L equals d plus r, remember, let me take you back over here. The total length L, this whole thing here, is equal to d plus r. Alright? I'm going to go back here now. Since L equals d plus r, you solve for d. D equals L minus r. And since r is equal to 2/5 L, let's plug that into here to get this one. L equals minus 2/5 L, and that's just equal to 3/5 L. Next, finally, that tells us that d divided by L is equal to 3/5. Now we can get back to question 3a. Okay. This argument that I showed you that says d over L is 3 over 5 is independent of, it's true for all L. That means that no matter how long or short I make the pendulum bob length, okay, d over L, the ratio d over L will be 3/5. So if I plot d over L as a function of L, okay, I should just get a flat line at 3/5. Now your challenge is to see whether your measurements bear this result out. So this is your hypothesis. Try to verify it using your measurements.